So welcome all of you. There are around 24. Can you see the screen? Okay, good. So now my first question is admit. My question is how many of you have solved it and found it very easy? You can raise your hands. I can see. Okay, have you solved it? I hope you have tried to solve the questions. And let me start off without wasting time. Please stop me in case if you want me to explain something more. I will maybe switch off the camera because it may be a distraction, and let me go question by question. Okay. So I want you to write the option on the chat window so that we'll see that you are already on track or not. Even if it is wrong, at least it will help me to clarify it. So please write your options so that it will be useful. The whole discussion is. First question. I'm showing you the first question. Can someone tell me what is the correct option for this? Okay. Okay. All of you are on track. Thank you. So just for there may be some new people on board. Model question paper discussion. Okay. So there may be some new guys who are wondering why is it C. You need to refer the slides. Okay, I am not going to explain everything that needed. The slides are very self-explanatory. One thing what I want to tell you is the number that you need to choose in the engineering units. It's called engineering units. We need to use this 10 power minus 3 minus 6. We say that milliampere. This is micro and nano. And then on the 10 power 3 side kilo ohms, I'm writing it in the reverse direction, but 10 6 meg ohm or whatever. So we write these short notations for in engineering units. So we need to convert the given number. Okay, there will be certainly one question on this. May not be the same question. Okay, so you need to convert it into the engineering units, which will be between 1 to 99 or 0 to 999. Okay, the number should be like that. And so none of these other options are actually giving you the range of value which is allowed in the engineering unit. So 235 microampere is the right answer. C is the right answer. I hope this short explanation is enough for you. But if you want more, you need to use one of these short notations to write the given number. Okay, you are not supposed to modify the value. Even if you are writing 235 microampere, it is same as what is given here. Only thing is you are changing the notation and the number that you are displaying it. Okay, this is called the standard engineering units. Okay, notation. Now, what about this? Very simple. Maybe I will try to see the answer for this. Maybe you can type the answer for the second question now. Can someone write the answer for the second question? Okay, again C. Okay, one more thing I'll tell you. Do not go by whatever option previously given. So that will not be the next question. Might have done some shortcut ideas in your JEE preparation. In my case or in our case, don't assume anything, because you might get the same option or different options, and it is random in nature really. So don't go by what was the previous answer, and don't try to predict the next answer. Now, okay, coming back to the question here. See, what is the tolerance? Okay, in a resistor. Okay, let me try to draw the resistor. Normally, how do you have to keep it? Okay, you have to three normally 3 different colors will be there, and then the fourth color is just little bit away from the rest of the 3 will be the tolerance, okay, color. It could be silver or gold, okay. Other colors are there, okay. This, there will be a distance between the 3 rings and the fourth one, so you have to hold it in such a way that you see the tolerance color properly, and then this tolerance actually gives you how good is the manufacturing of this resistor value is, okay. Suppose the color coding says that it is 1 kilo ohm. What you really have in the manufactured output of resistors, you have so many 1K resistors that we have used in our project, in our lab. Not all of them have the same values, right? Because of the manufacturing differences and the material that goes in, and there will be some differences in the values that you really measure. So from the given value, as per the color coding, how much it can vary, plus or minus percentage, is the tolerance level, okay. So if it is a gold, it means that it's a good quality, okay. There's a standard mechanism is there to find out what is the percentage. I want you to refer to that slide. But if I give you a percentage 5%, one resistor is 5% tolerance and another resistance is only 0.5% tolerance, that means what? Given the value, suppose this is a 1 kilo ohm resistor, the actual value that you measure by keeping a multimeter across the resistor could only vary from plus or minus 0.05%. Please remember, it need not be always more than the given value. It could be less than the given value also. But there is a range saying that it will be 0.05% of the value it is currently showing, okay, as per the color code. So in that case, what is better? Changing too much, like 5%, or is it 0.05% is better? So I'm sure some hanging is happening, so hold on. Okay, there is some problem with my OneNote. Okay, so coming to the answer, it should be the lowest 0.5% is the better option, because that has a less tolerance value. That means what you get is very less value is changing. So in that case, what is the correct answer now? I don't know what you guys told me. They said A. No, somebody said C. Now R2 has a tolerance of 0.5%, okay, whereas R1 has a tolerance of 5%. So please think about the explanation. After the explanation, what is the correct answer for this question? Is it A? Again, somebody is saying A. So C is the right answer. I don't know why somebody is saying A, Aditi. Let me tell you, A option says that R1 can withstand more power. So tolerance does not talk about power. So let me explain. Tolerance does not talk about power. It is only about how accurate the value is, manufactured value, to the actual value. What is the difference between that? So tolerance does not talk about the power. So option A is wrong, and right answer is C. Okay. So sorry, OneNote has crashed. Let me start again. Microsoft has some issues. Okay. So I hope it is clear. In case if you any of you have any doubts, please come back and ask me. You can chat or you can come online and then ask me the question. Otherwise, it will be a waste if you don't ask. So A is not the right option, and it doesn't talk about power. Tolerance talks about the value, how accurate the manufactured value of the resistor is compared to what is shown in the color coding. So if it is 0.05%, it is changing only this much, okay, 0.05% of the original value. Whereas if it is 5%, it's a bigger number, which is that plus or minus 5% is a larger number compared to plus or minus 0.05%, okay, to the given value. So R1 is a poor quality resistor compared to R2. So C option is the right option. Okay. I hope Aditi and Sudanva understand that. In case if you have still doubt, please raise it now. Okay. Okay, great. Thank you. So let me, I got the notepad again, one note. Okay. So let us look at this question. I want you to give me the answer again. Okay. B. Okay. B. So this is a very straightforward, and maybe for the benefit of people who are new, how do you solve it? Given a problem like this, how do you solve it? Let me show you. So some circuit, right? Whatever is given, let me show that circuit. Whatever is the circuit given, you have to backtrack it. Okay. Now, I don't know this. No, one note is giving me a issue. I thought this will. Okay, one second. Sorry, guys. Let me open the white board. Both Microsofts are giving problem. Okay, let me explain with the picture. No, both are coming up. Let us hope it works. So what you should do is from this X, I want the, okay, let me show the question. Okay, it's not visible. You have to find the input which makes the output 1. So you have to start from the front, from the output, and then traverse towards the input. So now it has got 3 inputs. Now this AND gate will give you 1 only when all these inputs are 1. So you have to now percolate this input to all the 3 inputs. Okay, so I don't know whether anybody joined now. Let me just check it. Yeah. Okay, so you have to give 1. You expect a 1 at the all the outputs, right? Inputs, right? In that case, then you know that this is C, which is has to be 1. Okay. In our case, A, B, C. Okay. There are 2 values which are 1 here. It could be B or C. We don't know. So then you have to look at other input, which is XOR gate or XNOR gate. Then you have to percolate now. Now, what should you do here? Now, suppose if this is 1, output of XOR should be 0. Output of XOR will be 0 only when this input and another input which is supposed to be here are the same. Okay, isn't it? So only when it is same, you will get XOR will give you 0 and then not of that will give you 1. So we need a 1 here. In that case, B is also 1. So you found out C and B now. I think you are close to the answer now. Anyway, we can verify it because none of the above option is also there. So you cannot in between decide that output is this. So this is 1 and the output has to be 1 here. That means this needs to be 0. So A has to be 0. The value A, B, C, 0, 1, 1. So whatever I have written A, B, C here, you have to say that this is also given as a ABC. So please don't get confused there. Whether C is the LSB or MSB, you may have a doubt. So in that case, the correct option is B. Okay, I think you got it right, some of you. In case if any one of you have any doubts, please raise it now. You may not get the same circuit, but you may get some different circuit and you need to do the same logic of going from the output to the input. Or it could be different. Please don't think that I will ask the same kind of question again. Okay, it could be maybe something different also. Please don't assume the same questions will come. Okay. Now, what is the answer for this? Anybody wants to go? The fourth question. D. Okay. So how do you find out? Okay, that's that we will explain. I am not sure. I will not tell whether this is wrong or correct or whatever. Okay, I hope this works out fine. So here also, I want you to find what is the relationship between X and F. Okay, F is the output, X is the input. What is the relationship? So you have to painfully, find the output by, now you have to do it from input to the output. Okay, so let me draw it. Okay, now what you should do, what is the maximum, now what is the different values that X and 1 can have? X value, it can be either 0 or it could be 1, right? So maybe I will choose a different color for 1. Now you need to, if you want to find the relationship, pass a 0 and then find out the F. Okay, you have to draw a truth diagram. Okay, you have to draw a truth table and then find the relationship between X and F. So X can have a 0, then what will be the value of F? So assume that 0 is given. Now this is 0. Oh, sorry, this has to be here. Okay, let me erase it. Okay, I hope you guys can understand it. Okay, this is not connected. Okay, okay, this is 0. Okay, now let me show this question paper. The same input is given here, so you will have a 0 here and 0 here. So same input, output will be 0. Now this is 0 0, so output is 0. This is 0 0, output is 0. Okay, so for 0 input it is giving you a 0 output. Now let us see what if I give 1. Now 1 is coming here, so 1 1, again it will be a 0, because same input will give you output as 0. Now this is 1 and 0. Okay, this value is 1 and this output is 0, so this will be 1, and this is again 1 here. 1 1 will give you 0. That means if X is 0, F is 0. If X is 1, again F is 0. So it doesn't change with the input value. Okay, you cannot say it is F is equal to X. In that case, if given 0, it should have been 0. If I given X as 1, F should have been 1. So that first option is ruled out, and it is not the complement of what I give. Okay, and it is not equal to always 1 also. It is always equal to 0 irrespective of whatever value of X I give. So F is equal to 0. Okay, that is always 0 irrespective of X. So the option D. Okay, this is how you should solve a problem like this. Okay, I hope other than Hussain, others are also with me. In case if any of you have any doubts on the explanation that I gave, feel free to come back and ask me any doubt. See, what you should do is, in this case, if I am trying to ask you to find the relationship between the input and output, you have to assume what are the possible values the input can take, and then give those values and find the values of output and verify it. Okay, you'll be able to find out which one of them is suiting or matching with the output that you get. Okay, it depends on the circuit, and you need to painfully go through it and do it. Okay, I hope this is clear. And anybody for going for this fifth question? C. Okay, let me check whether. Okay, anyone else giving a different answer? Okay, very good. Thanks, Suzanne. 2310 is a decimal value. So we will represent the value with this number. Okay, 23 could also be 8 also. 23 could also be 16. Okay, so never assume, unless I give you this, never assume that it is octal or hexadecimal. But in case if only 23 is given, you could assume that it is a decimal number, unless I qualify it as octal or hexadecimal. So I want you to assume one of this and then write, or in case if you have doubt, you can always ask me in the exam also. Now in this case, hopefully there is no ambiguity. 23 is given as a decimal number. So what you need to do, the 17 is given as hexadecimal. So find out the equivalent value of decimal equivalent of this number, which is nothing but 16 to the power 1 into 1 plus 16 to the power 0 into 7. So which is nothing but 16 plus 16 to the power 0 is 1, 1 into 7, 7. This is equal to 23 in decimal. So this number is exactly same as what was given. So you can't say no or can't say none of the above. So please say yes, like what Hussain did or Nandish did. So the right answer is C. Okay, good. So far so good. What about this question number 6? What do you think is the right answer? So there is going to be only one right answer because all of you wanted it. Otherwise, I could have asked multiple right options also. We could have planned that way, but let us make it simple for time being. So what is the answer for the 6th question? Anybody? Let us be quick little bit. Okay. It's A. Computers are built with digital circuits which can only be in 2 states. I know that I told you many times. It's a digital circuit, 2 states. Non-binary data takes more time to process. I agree. Non-binary data takes more time to process in terms of analog computing, but that is not the reason here. Okay, we are using binary. We are using because we want to use it for computers to manipulate numbers. All the data in the real world are in binary format, which is a wrong statement. If you choose this option, maybe negative marks should be given, but I won't give you. Don't worry. So the right answer is A. Okay, very obvious. And convert the hexadecimal number given to octal format. The simplest thing is I will not go through solving it. Maybe I will give you the answer 472. Okay, let me check whether your number is correct. I don't remember. Oh, which is the question? Oh, I did not. I have not written the key for it, I think. Okay. Okay, I will have to do that. Yeah, 472 is the right answer. Yeah, you are right. So what you do, how do you do it? Maybe I will not go into the details of this, exactly what to do. So given a number, okay, you do 16 into 2, 16 to the power 2, sorry, and then plus 3 into 16 to the power 1 plus 10. Okay, A you have to replace it by 10 to the 16 power 0. So please remember A, B, C, D, E, F, which corresponds to 10 to 15. So you have to compute this decimal value. Okay, compute decimal value, then go to octal representation. Okay, if you want, you can do the division by 8, whichever you are comfortable. Do the sequence and then find out the octal number. In case if you are in doubt, please write the number, okay, and then verify it. Okay, and please write it, suppose whatever 472 to the base 8. Okay, write it that way so that I know that you understand that representation is important. And the answer is 472 8. Okay, the answer is 472 8. Okay, you can verify it. This you can verify it by 4 into 8 power 8 square and then 7 into 8 plus 2. Okay, that's all. This will be equal to whatever decimal number you get here. Okay, very straightforward. I hope you guys can understand it. Okay, great. So what are the gray codes of 0 values of binary values? Okay, you can always write 4-bit also, and or in this case the Better option maybe, I'm not saying that it is wrong, because only 4 values are there, so you can only write it as sorry, yeah, 10. Okay. Aditi wrote it this way. This is a binary representation. What you have written, Aditi, is a binary representation. But what we are asking, what is the question is asking, is a gray code. Please remember, you need to look at the slide of gray code, which is a mirror image. Okay. I'm sorry, I use this. How do we construct a gray code? Initially, you start with 0 and 1, and then you find the mirror image of that and add 0, 0 to it and 1, 1 to it. Now, the first binary number, one more thing you remember, what I mentioned in the class, gray codes do not have any weights associated with that. Okay, you cannot find the value of that to the 2 power 0 or 2 power 1. Okay, gray codes are computed like this, starting with 0, 1, that's the two values. Then find the mirror image. Okay, there was a slide in that. Okay, anyway, and then what you do is add 2 zeros and 2 ones. Okay, all the numbers above this will be, put a 0, 0 here and all ones here. Now, how do you expand it further? Okay, let me do once again how to do it physically, maybe. Okay, if you want to find out, suppose this is 0, this is 1, this is 2, and this is 3. Now I want to know what is the value of gray code for 7. Now what I do a mirror image of this. Now mirror image means this number 1, 1, then 0, 1, and 0, 0. Okay, exactly reverse of this order. Then what you do is add zeros to it. Okay, because, and then this value would be 4, this is will be 5, this is 6, and this is 7. Now, oh sorry, this will be, yeah, oh sorry, I'm sorry, this should be all ones. Okay, all ones. Okay, these are all zeros you have to add, all ones you have to add. So 100 is the answer for 7. Okay, in case if I ask you what is the equivalent gray code for number 7. So I don't want you to mug it up. Okay, this sequence you can actually derive it. It depends on your memory capacity, but preferably do not mug up. Okay, so that's the reason this is like this, Aditi. I hope you got it. It's not what you have written is a binary sequence. Okay, gray code is different from binary sequence, which is used in KMAP. So please pay attention to that. Okay, it's okay if you are wrong here, but preferably you can be correct in the exam. Okay, Aditi, is it okay now? Can I go forward? You have still doubts? Okay, thank you. So gray code is, maybe there will be some code on questions on gray code, because it is very important. It should know. Now let us look at the number 9, question number 9. A and B are two gray codes. Okay, just randomly I have taken two gray codes. Okay, when you examine the binary bits of A and B, you notice that value of only one bit is different from each other. Okay, now let me take randomly, let us take some two numbers. Okay, here whatever we have created, let me look at these two numbers. Okay, now if I look at it, adjacent number, I'm picking up adjacent number, you see that only one bit, this bit and this bit are different between them. Okay, only one bit is changed. Okay, these are all same. Now suppose if I take random, now some two bits here this bit and this bit are same, but this and this, it happens to be that LSB I am picking up, but maybe if I pick up these two, you will find this also LSB is changing, because if I pick up these two, maybe you will find that MSB is changing. Okay, between these two numbers, if I take 3 and 4, you will see that the MSB is changing, remaining one is all same. So always the gray code adjacent numbers will be only one bit will be changing. That's why it's called unit distance coding. And if it is only one bit is different from each other, then nothing can be said about the sequence of A and B, or A and B are adjacent numbers, A and B are not adjacent numbers. Okay, it is A and B are adjacent numbers. It could be one is which is above or which is below is not our discussion. they are adjacent numbers in the gray code notation. Okay, so in this ninth question, B is the right answer. Okay, I hope nobody came up with the answer, but I hope it is clear. Okay, I will go forward unless there are some questions from anyone. Okay, parity bit. So it's also very important. Now I have given a data which is 1 0 1 1 1 1 0 1 0. So remember, the data portion could be a 8-bit data, or I could have maybe a 16-bit data. It doesn't matter. Okay, but parity bit always is 1. Okay, normally parity bit is 1 bit is reserved. Normally it is given at the MSB of the data. Okay, because any circuit, digital circuit that it has to look at all the input and then derive the parity bit, whether it is 0 or 1. It should find out from the input given to it. Now what is the purpose of parity? It is to find out whether a given data along with the parity is received properly or not. Okay, what it means is, it is used for communication channel, wherein you have one TX transmitter is sending some data to the receiver over some communication channel, maybe a serial port or maybe a wireless communication or optical communication. It doesn't matter what you use as a medium. When the data is sent over any medium, air or optical cable or maybe electrical signal, there can be a noise picked up, and either 1 or 0 what is being sent is some voltage level or a light intensity level could be modified in transit. When the data is in transit, it could be modified. Now this parity is used for verifying whether the receiver is receiving it in a proper way or not. What is being sent is what is received or not. But how is it finding out? Okay, let me tell you. Suppose I have a 8-bit data which is given. Okay, let me take this data only. Okay, sorry. This data. Now I want you to find out. Let me first read the question again. You are given a 8-bit data along with parity bit. Okay, it is parity bit is generated based on this 8-bit data. Assume that there are no errors in the data and the parity bit. There are no errors in the received data. Okay, what you are shown is the actual content which is received, and it has been, parity bit has been generated already and it has been received without any error. It says that without any error. Okay, if the value is as shown below, what was the parity being followed? Okay, what was the parity being used by the sender, and what is the parity that receiver is told? See, remember one thing, that the sender and the receiver should know what is the parity being followed while the data is being sent. Okay, it could be odd parity or even parity. Okay, this is purely a choice of the designer, of the sender, and it is a choice between the sender and the receiver. So they should be already informed. Okay, what is the parity is going to be followed for particular data transmission. Now I am saying that the data is received properly. That means no errors in either in parity bit or in the data portion of the data. Okay, bits. That means all the data which has been sent is received as it was sent. In that case, you can rely on the parity what was being shown. Now, how is the parity found out? Now, if you are following a odd parity, what is done is the number of ones in the data is counted, and then the value of the parity bit is chosen such that the total number of ones including the parity bit is odd. Okay, the value of this is chosen in such a way that the total number of ones including the data and the parity is odd numbers. Now I said that this data is received properly. That means now how many ones are there including the parity bit? 1 2 3 4 5 6. 6 ones are there. 6 ones. Okay, that means what? It is an even number and the data and the parity is received properly. That means it should have been an even parity. Okay, that's why the parity would have been set as 1 for the given data. If it was an odd parity, then the number of ones are already odd here, so it would have been 0 here. Okay, so the fact that it is 1 and the number of ones in this whole information is even, then you will know that the parity being followed is a even parity. Okay, so the answer for this is A. Okay, so I hope my explanation and the answer what I am giving you is correct. Sorry, it must be correct, hopefully, and then you understand it too. Okay, fine. Now let us come to binary numbers. Convert the following binary number to octal format. So again, the same philosophy of bringing it to your comfort level. Okay, bring the data to decimal. Okay, bring from binary to decimal, then decimal to octal. Okay, that's a route you can take. Okay, so please follow that. And answer, let me tell you, it is 212. Oh, sorry, 2128. Okay, oh yeah, 2128. In case if you have done already, yeah, Nandish and Vipul has already done, and I have also done, and looks that all of us are right. So any one of you having any doubt, please look at the thing. Just you know that binary conversion, 2 power 0, 2 power 1, you have to go and then find out the value of in decimal and then convert it into octal format. Okay. So please don't think that only octal will come. Maybe hexadecimal also could come, because more of hexadecimal is what I want you guys to be aware of more than octal. Please take care of that. Okay, what about this? Construct a 5-bit odd parity generator circuit. Let me show the picture directly. Uh, okay, I yeah, this is the circuit. What was asked was odd parity. So there will be a not only at the end. Please don't put any not inside. And this circuit is already given for a 4-bit. So 4-bit. You have to add one more gate and then put the not at the end of it, and this will be the circuit. Okay, I hope it is clear. Please refer the relevant last, I think 2.2 is where we learned about this, section 2.2. Please read about it. Okay, I don't think I need to explain anything further. We are also running out of time. So let me look at the question. Where is it? So this is very clear. Now what about this? Okay, please don't get confused with this circles at the end. It's all like a terminal. Okay, don't think that it's a not gate or something and then try to do a not operation. Not operation is always valid only when the circle is given along with the gates. Okay, any NOT gate or OR gate or whatever. Okay, so if it is just a given, it's a terminal. Okay, where you are taking the input or output, or where you are giving input or output. Okay, so 3 input XOR NOR gate, very straightforward. You have to painfully write the table and then write all combinations. Let me show you. Make sure that you don't miss out anything. Here, the combination that you write is in a binary sequence. So value is 0, 1, 2, 3, 4, 5, 6, 7. And then find out what is the value of operation. You need to draw. Please, for the exam, please bring some pencil, scale, or whatever, and then even writing pad you bring it, because the room that we choose may not have a proper writing table. It could be a chair with maybe a pad or writing pad may be there, but you bring your own writing pad so that you can keep your answer sheet on that and draw the things whatever is required. The simple diagrams you may draw, and please try to draw as clean as possible. Okay, I don't want you to draw it shabbily. Okay, there will be some marks for that also, but don't spend too much time in making it beautiful and all that. Okay, correctness is more important than uh, cleanliness. Cleanliness is also good, but more importance will be given to the correctness of the thing, and it should be clear. Okay, I should be able, we should be able to make out what you are actually drawing. Okay, so don't miss out any combination. You need to write this answer like this. Okay, that's all. And what about this? Okay, this question is order is reversed, not intentional. It doesn't matter. Order in which we taught you need not be the same in which questions come. So now, how do you solve this? Okay, The simplest way, if it is a single loop, okay, anything, what is sources are there, you can all group them, okay, group them all in one side, okay, and then group all the resistors on the other side, okay. Um, Please remember, only if they are all on the same loop, okay. If there is something like this, please do not try to group them, then the behavior will be different, okay. So you need to make sure that same current is flowing in this circuit, all the voltage sources are getting the same current, okay. So you are like, you are okay to move them all together. Now while moving, make sure that you do not miss out the polarity. Like 1 volt, if you are moving here, make sure that plus is here, minus is here, and then plus of this is connected and minus is connected, and 10 volt is here, okay. When you are moving it, make sure that you don't interchange the plus and minus, otherwise the results will be different. And then what you do, go from one direction, and if you encounter a minus terminal, put -1. If you encounter a plus terminal, plus 10. And another source which is minus plus, which is 1.5, minus 1.5. Then another one is minus 1.5. Okay. So like that you keep adding them. Okay. All of them. Polarities be very clear about it. And then the resistors doesn't matter. Okay. I can add them all in R equivalent of series resistance is just an addition of all the numbers. So what you get is uh, 10 plus 2. I have put it in this order. Okay. Remember, the -1 is very important. Okay. I will tell you why. If you miss -1, if you write only 1 ampere, maybe we will reduce completely all zeros. Actually, it should be, but let us think about that after I discuss with CVS and sir whether I should completely give 0 for it if you give 1 ampere, or maybe partial mark. It should be, yeah, Nandish, I am just discussing about you whether I should give you 0 or little bit less than that. Remember, this I is given as a direction is given this way, and you have to, when you write the equation, you will get value like this, and it should be -1 ampere. Okay, I hope Nandish you get it. There is some mistake in some addition you have performed, and it should be -1 ampere. Do you get it? Please, I don't know anyone of you got into the same error. Um, Please let me know in case you guys are getting confused. Here it should be a -1 ampere. Okay, correct answer. Okay, maybe there some careless mistake. Please take care of that. Okay. Any questions on this, guys, from anyone? Please come online and discuss. Otherwise, I assume you are all with me and you follow me. And I am recording this lecture also. Whatever, I hope it is getting recorded. Yes. So I will share it on Google Classroom. Okay. Fine. Let us. I have already shown the answer for the other one. There is no secret. Let us see. Here also simple. You have to add the plus will be here, and then you need to add them. Okay, and that will be like 20 volt divided by 5 is 4 ampere. Okay, that's the voltage. And remember the direction of the current what I am showing. In case if it is different, you need to write minus. Okay, I explained to you in the first lecture itself. If current direction is different, -5, 5 ampere. If you change the direction, it is -5, plus 5 will become -5. Okay, fine. I hope it is clear. It's not very complex. Now this you might have solved it in your JEE main preparation. You have to write it in a little different way without correctness is compromised. Okay, this is how you should write it. Okay, this little confusing, but if you push it, oh sorry, here I'll have to write one more resistor. Okay, one more resistor, 2 ohms here, 2 ohms here, and then 2 here. And so painfully you need to add this 4 and then parallelize it, then sequentialize it, then again parallelize it. So please go step by step. Even if you make mistakes, if you have put the steps, you will get marks for the steps. So do not jump to answer directly. Please write the steps as clear as possible. It's okay. Time also is important, and make sure that you show that you have derived it, because you will get marks for the steps also. Like it's not a multiple choice question where you are to give the final answer. Steps will have marks, okay? Otherwise there will be some reduction, because it could be that people will suspect that you have copied from somebody. So don't try to do it mentally. Try to write it at least, even if it is simple, write the steps so that you'll get marks for it. Okay, I have written it like this. Don't I will get maybe partial mark here because I have not shown you the steps. Okay, now what about the PNP NPN transistor? And very simple, it's already given. Remember the equation that you need to have in your mind. Okay, always remember the emitter current is more, okay, because that's a source for the transistor, and the direction of the current is same as what is shown here. So IE is here, and if you consider the transistor as a node, okay, single node, whatever current goes in has to come out. So imagine this is the IE current which is coming out, and IE is the source, okay, even though the direction is like this. These two have to be input of the direction of these two should be different from the IE direction, okay. So equation is IE is equal to IB plus IC, okay. So the directions of IC and IB will be like this, and KCL will give you, the transistor doesn't store anything. It gives out all the current that comes in. So if IE is coming in here, they will have to go out like this. If these two currents are given as IE, okay, here also the current is actually drawn by or given by the emitter, but the direction flow of current is reversed because the majority carriers in NPN is electron. Please remember, this is the NPN transistor and majority carriers are electrons, okay. That's why the direction is like this, okay. Whereas in PNP transistor, the majority characters are holes, and the direction of current what is shown is equivalent to the direction of the IE here, okay. That's the reason, okay. So you can write it like this. Any doubts here? Nobody is having any doubts. I think they are looking at the watch now. Okay. Okay, so this is little thinking involved. I want to see if anybody is giving me the answer for this. Anyone wants to go for it? Doesn't matter whether it's right or wrong. Have you anybody solved it and then found out the answer? I'm waiting for your answers. Nobody? Okay, nobody wants to go for it. No one wants to be wrong. I don't know. You should not be afraid of being wrong. Okay, now how do I solve this given a problem? Okay, you have to use the induction principle. Okay, you know what is induction, right? Give one or two and then see how it behaves, and then you will know. Okay, this is 0, okay, always 0, and this is a x. Now what are the possible values x could take? Either 0 or 1, similar to what I explained you in the previous case. Now let us assume a 0 is passed as x, and I want to check what is the output, okay. Now these are all connected. Now I have given 81 XOR gates. You cannot draw 81, so let us write odd number of, okay, sorry, let me erase it. Okay. Okay. Now let us put odd number of gates, okay, and then we'll see if I put odd number of gates and even number of gates, how does it output changes. I don't need to change, look at the even option because 81 is an odd number. So if I put odd number of ones, XOR gates, the behavior will be repeating. Okay, so let us look at the 0. Now if I put a 0, if I give a 0 here, this will be 0. Now this is 0, this will be 1, correct? Sorry, this is 0. 0, 0 is 0. And then again this will be 0, so this is 0. This again, because the same x is coming here, so everything is, all 0 is going in. Okay, so if I have a excess 0, 0 is going out. Okay, now let me choose another color, which is better. Let me choose this, or let me choose this. Now I can't change this value because this happens to be 0 always. Okay, but x can take a value which is 1. So let me give, instead of 0, let me give a 1 now. Now what happens? This will be 1, here also 1. Okay, that's all. Input is all becoming 1 now. But this is 0. Okay, please remember that is 0. Whatever is given value, it is constant. But output of this will now change because 0 and 1 will give you XR as 1 here. Now what happens if 1 and 1 are there? It will be 0. Okay, and then 0 and 1 it becomes, so it becomes 1. Now what is the relationship between the number of gates and the output? If I have odd number of gates, XOR gates, even if I leave it to as home exercise, you put a 2 more and then 5 XOR gates you put it, what will happen is the behavior will be different, same. Okay, it becomes 1 and then becomes 0, then it again becomes 1. Then what happens is, whatever is the value of x I give, right? If I give a 0, x is 0. If I give a 0, I get 0. If I give a 1, I get 1. So the output value y is equal to x if I have an odd number of XOR gates. Okay, I can extrapolate it because 81 happens to be odd. So I need to check whether if I add 2 more XOR gates, what will happen, or if I have only one XOR gate. Okay, will also be it will be similar to whatever value of x is. If x is 0, I get a 0. If x is 1, I get a 1. So that's how you need to find out, and you need to say what is the value of y. Y is equal to x. Okay, you have to say y is same as x. Okay, capital Y is same as x. So this is the answer. Now in the exam, what you would get, you may get XOR gates or sequence of NOT gates or OR gates, or you may get odd number of gates or even number of gates, or you may get different input. Okay, constant input what is given could be different. So please be ready with some questions which is similar to this type in the exam. Okay, there's going to be similar question, but will it be different? It will be different certainly for sure than what is given here. Okay, so answer is x for all odd number of XOR gates. Remember, even and odd, they are different. Okay, in case let me tell you, for the same circuit, if I get even number of OR gates, suppose if I say that there are 82 gates or 92 gates, what will be the output? Whatever x I give, you are going to get a even number of even number of things. If I give 1, so I get to get 0. If I get 0, I'm going to get 0. So it's going to be always 0. Okay, if I am having even number of gates, it's going to be always 0. So output y will be 0. If I say that there are even number of gates in this for the same circuit, instead of 81, if I say some even numbers, output will be always 0. So there could be different combinations. I want you to try it out yourself and understand exactly. Okay, what you are supposed to do is, if we give any variable, you have to assume that it could take any two values. Okay, 0 or 1, and then understand the circuits, what will happen to the output, and express that output. Maybe you can create a truth table and then see for different combination of input what is the output, then write the equation. Okay, it could be a 0 or 1, or it could be same as x, or it will be x prime also. It could be a complement of x. Okay, x bar. Okay, Yeah, this is only for XOR gate what I am saying. But if different gates are given, you need to apply that and then find out what is the value. Okay. So yeah, you are true. You are right. It's only what I am explaining is for XOR gate, and you need to do the same thing for different type of gates. Okay. Is it clear, Abhishek? Because you came back, at least I can ask you. Others are quiet. I don't know whether they are clear. No answer from Abhishek. Okay, thank you. Uh, Please ask me any doubts. Okay, I am available. You know my mobile number. To call me, send me a message. And when you are sending message, I appreciate if you can say that what's your name, at least so that I know that it is one of you. It's not somebody from SPA or some other bank asking some question. So please write your name and then I will show your number in this required. So please you can fire a question to any one of us on the Professor CBS and me. We are all available as we mentioned that we are on WhatsApp. But if there is a delay, please wait. We will certainly get back to you. Oh, okay. I hear that my voice is breaking. I don't know. Let me check whether our voice is okay. Yeah, I am on audio. Uh, so okay, don't worry. In the recording will be there. Okay, which will be having the proper audio so that we can always get it back. So finally, full data circuit is taken from 2.2, section 2.2, and then let me explain what is expected of you. One second. Let me open 2.2. So we'll complete it in 2 minutes. Because of recording is happening, my laptop is starting to open the PDF. Okay. Okay. So this is a secure. What you need to do is look. You want to use the value. So you can take any input. Okay. You can three input. You can consider 110 or all ones or all zeros or whatever. Any combination. Please, I don't want the same input in all the papers. Then I may have some doubts on what is happening in the example. Otherwise, it should all have different inputs and intermediate values, please write, and then output. So if you are having doubt, please expand this order, put an extra get and get here so that you will not make any mistake. So draw all the, sorry, write all the inputs and outputs, intermediate outputs, and finally the do output that you get. Okay, that's what is expected of you in the question, what is mentioned here. Where is it? Yeah. Draw the full data set and give a sample input. Okay, sample input. Okay, you know that full data takes three input and output is two outputs and intermediate values are what I mean by the intermediate values. Okay, what is going into P and Q and what comes into RE. Okay, that's all. I hope question is clear and what is expected of you is clear. Then what about the last one, Q point? Okay, this is also diode. You need to draw the okay. Okay, not audible. Okay, I don't know whether can you hear me? Okay, no issues. I will be sharing the recording. Hopefully, the audio should be fine there. What you need to do for the diode characteristic is you draw the forward biasing as well as reverse biasing, and then write what is the current direction, what is actually ID and VD, and cutting voltage. Please mention those things, and that's what we're supposed to do. Okay, for the last question. So I will stop here. I don't know whether you guys can hear me properly or not. Any questions before we drop? Okay, thank you for joining. Please, okay, there will be some questions with the current source also. So don't think that only this kind of questions will come in the exam. Please read all the slides and all the sections from 1.1 to 2.2 and try out different problems so that you are ready for the exam. Okay, see you soon and have a happy vacation and wish you all a happy new year. Bye bye. Yeah, the next question also will be there. Maybe we will have a question on the resistor Q. I may not ask you to derive the equation or something. Maybe I will give you some input current and ask you to what is the point output and whatever. But please go to the lab also. Okay. There were no questions from lab actually here, but there will be some questions too. Okay, guys. Okay. Thanks for the question. Okay. Any other questions from anyone? There will be a review session because nobody is coming to the class. Many of the last sessions are he plans to do it tomorrow. You can join and then he will also be on Google Meet like this and then we can you can go over we may go over some of these topics or based on whatever doubts you have we can find it out. Okay. So all the best. Have a nice day and a nice vacation and happy new year. Bye. See you. I will drop off now. Thank you guys for joining.